Hello dear children, welcome to the fourth video for the lesson Separation of Substances. In this lesson, so far we have seen different separation methods for the separation of solids from solids, both soluble as well as insoluble solids from liquids, as well as miscible and immiscible liquid mixtures too. In this video, we will be learning about the importance of water, made aware of what the water crisis is, and the need for voice management of potable water. You'll also be familiarized with the different stages of water purification process. You'll learn how to differentiate between a saturated and unsaturated solution, and you will learn the importance of water as a universal solvent. So why do we need clean water? Well, you know that water is essential for humans, plants, and animals to survive and for our various daily activities. For us to be hygienic, we require water. Contamination of water, as we've already learned, causes many contagious diseases such as typhoid, cholera, jaundice, diarrhea, and polio. So these diseases can be really widespread if there is contamination of the microorganisms in the water that is supplied to an area. Again, nearly 1 billion people in our planet today do not have safe water to drink. And every 15 seconds, a child dies from lack of clean water. 1 in 4 children who dies before the age of 5 worldwide, they die because of a water-related disease, the kind of diseases that we just saw. So when it happens in really rural areas where there are no hospitals or no medical facilities immediately available, it can lead to the death of the person who is suffering from these diseases. The saddest part is that many children in our country even today, they walk miles every day to collect water to drink, and this water might not be even safe for consumption. And in this process, because they need to go out and fetch the water for their daily use, they do not attend schools, or they might even face really hazardous or dangerous conditions to bring the water home. So I hope you are now aware of how important water is, why we need to take care of water, and the water crisis that the world is facing right now. Most of the major metropolitan cities of the world are facing a very serious threat of not having enough water for distribution, for use. So purification of water plays an important role, first of all, to make the water clean and fit for human consumption, for use, as well as it gives us the chance to reuse whatever water we can salvage from the wastewater. So, a process by which all the germs and harmful substances in the untreated water are removed and then it is made for drinking is called as water purification. And the water that is safe for drinking for usage is what we call as potable water. Let's take a look at the different steps involved in purification of drinking water. So most of the water that we consume comes from the water that is stored in reservoirs, in dams, which actually are a direct source from the rainwater, and the water that comes in from reservoirs, they move to water treatment plants. They have to first of all go through a screening process. The screening process is a process in which large particles of dirt are removed from the water, like leaves or maybe plastic or any sort of floating waste is removed from the water using a mesh or a gate. Like this, it is removed. So this process is called as the screening process. The second stage in the water purification process is the stage of loading and sedimentation. So what is sedimentation? We have already learned that when the water contains insoluble solids which are heavier than the water, it settles down when you allow it to stand, when you allow it to rest, when you give it some time, it just settles down to the bottom of the tank, and the water at the top, the clean water at the top, can be decanted or removed and cleaned by filtration process. So to aid the sedimentation process, it really helps if the size of the particles are larger, and this process is aided by the loading process. The loading process is a stage in the water purification process where a substance called as alum is added. Alum helps the different insoluble solids, the smaller pieces of dirt, to basically join together, and creates larger uh, larger particles of the insoluble solids, because they kind of join together and clump together to form larger particles. So when an alum is added at this stage, so said before the sedimentation stage, it allows the sedimentation to happen much more faster, and the water from the top can be decanted and then filtered. So the filtration is not done using any sieves or strains, but the strainer that is used is actually a sand filter. It is usually a sand filter. So there are several layers of fine sand, uh, followed by gravel or even coarse gravel, and the last layer would be coarse gravel, the larger pieces of gravel. It acts like a filter, and when the water passes through these three layers, the smaller to the larger particles of dirt which could be there in the decanted water is filtered. So sand filters are very commonly used even for filtration of the water in swimming pools. After the filtration process, there might still be some microorganisms remaining in the water which are too small to be picked up by the sand filters. And these microorganisms have to be killed or have to be made ineffective by the process of chlorination. Chlorination is the fourth stage of the water purification process. In the stage of chlorination, some chlorine is actually added to the water, and chlorine basically kills. It's a very good disinfectant. It kills all the microorganisms in the water, the harmful bacteria that could be present, and it makes the water safe for consumption. The chlorinated water is then stored in storage tanks before it is supplied to different parts of the city. This is the five-stage process by which water purification is done. Now, water is essential for life on Earth. Why do we say that water is absolutely essential for life on Earth? Because you've learned that water is actually a universal solvent, and this means that water can dissolve almost most of the substances uh, around us, can easily dissolve in water, or at least can dissolve in water up to some extent. Plants, as you know, absorb their nutrients through the roots when the nutrients and the minerals are dissolved in water. Again, whatever food is prepared by the leaves of the plants is distributed throughout the plant to allow the plant to grow, because it is having water as a medium of transport. You also learned about the process of transpiration, by which water is actually lost from the leaves. So it is a sort of way in which leaves actually sweat, or they regulate their temperature. So water dissolves more substances, and it acts as an important medium for absorption, transportation, and distribution of nutrients, not only in plants but also in animals. We have learned that our bodies are mostly made up of water. Water helps to throw waste in the form of sweat and urine in animals. And yes, aquatic life would have been impossible if oxygen did not dissolve in water. We know that gases also dissolve in water, and there is dissolved oxygen present in water, which makes it possible for plants as well as animals to live in water also. So, water is essential for life on Earth. Now let's talk about solutions. A solution is a homogeneous mixture, meaning that it will not separate on standing. A solution is a mixture that is formed when one or more solutes dissolve in a solvent. We have already learned that a solution is made up of a solute, which is a solid substance, which dissolves or can uniformly distribute in the solvent. Solvent can be water or any other liquid. The solvent can even be gases, which you will learn in later classes. But for now, we will consider our solvent as a liquid. So when sugar, which is a solute, dissolves in water, which is a solvent, you get a sugar solution. Similarly, you can have a salt solution if you dissolve salt in water. But then comes the question, what, can you dissolve any amount of, say, salt or sugar or any other solute in a given amount of a solvent, that is water? Is it possible to do that? Well, it's been seen that if you take 100 ml of water, H2O means water, you can dissolve, safely dissolve, easily dissolve around 30 grams of salt in it. So you can easily dissolve 30 grams of salt in 100 ml of water. Now, after dissolving the 30 grams of salt completely in the 100 ml of water, you can maybe dissolve a little bit more salt in it, a little bit more, maybe another 2 to 3, 4 grams you can dissolve in it extra. So we call this solution into which more salt can be added as an unsaturated solution. We call it as an unsaturated solution. Why do you call it as an unsaturated solution? Because you can dissolve more of the same solute in that solvent. You can still dissolve more of that same solute in that solvent. So it is called as an unsaturated solution. Now, what if you added 40 grams of salt? That is, additionally, you added 10 more grams of salt. You will see that no matter how much you stir it, no matter how much you allow it to stand, there will be around 4 grams of salt that remains undissolved in this solution. This is because this solution has become what we call as saturated. It cannot take in more of the solute. It cannot take in any more of the solute. It has become completely saturated. Think about it. If there is a bus and there are, say, seats for around 20 people to sit down, all 20 people can sit down on the seats. You can fill in maybe another 8 or to 10 people who are okay with standing in the bus. But then you will come to a point where you cannot fill in even more people into the bus because it is impossible. There is no more space for people to sit or stand. And that is when we say that it is a saturated state. The bus has become saturated. There is no more space in it. So you can think of a saturated solution as that kind of a solution in which no more solute can possibly dissolve. So I hope you've understood the meaning of what a saturated solution is and what an unsaturated solution is. But is it really impossible to dissolve any more solute in in a saturated solution? Let's take a look. What about sugar syrup? So you must have come across sugar syrup in some of your favorite mithais like gulab jamun or say rasgulla will require a kind of a thick sugar syrup to be used. So a sugar syrup is basically a very saturated solution of sugar and water. How is it possible to dissolve so much of sugar in the water when no more of the sugar would dissolve if it is a saturated solution? Can you think of some ways in which you can dissolve more sugar in water? Yes, definitely mixing or stirring it continuously would help dissolve some more of the sugar in the water. Another simple way to easily dissolve a little bit more sugar in your already saturated solution is by heating it. So this is a very important thing to remember. Heating can easily allow more solute to dissolve in a given solution. So the definition of a saturated solution is always for the maximum amount of solute that can be dissolved in a solvent at a given temperature. Because whenever you change the temperature, if you can increase the temperature, more of that solute can dissolve in any given solvent. Because heating always increases the solubility of solutes. So heating is a very easy way to prepare a sugar syrup, which you must have seen many times. Powdering the sugar is also another option. So when you are not able to heat the water, maybe what you can do is you can take the sugar and you can really um, pulverize it or powder it into really small particles, which allows it to dissolve more easily in the solution, in the solvent. So this is another easy way to prepare a sugar syrup. So remember that heating always increases the solubility of solutes, and when we describe or when we define a saturated solution, it is always the maximum amount of solute that a solvent can take at a given temperature. Now let's recap what we have learned in this video. In this video so far we have learned about the water purification process, which is a 5-step process. The first step is the screening process. The second is the loading and the sedimentation process, followed by the decantation and filtration process. And then we have the chlorination process to kill any harmful microorganisms, followed by storage and distribution. We've also learned about saturated and unsaturated solutions, and we have learned the importance of water for life, because water is a universal solvent that acts as a medium of transport, a medium of absorption, and a medium of distribution of nutrients as well as waste products inside all living organisms. So then, dear children, we have come to the end of this lesson, separation of substances. I hope you have understood the lesson really well. So keep learning and have fun with science. Bye bye. I'll see you again in the next video.